Hello world. Right now, your code runs from top to bottom, every time, every line. But real programs don't work that way. Real programs look at the world and decide. They branch, they choose, they skip. Today, we add the most important thing missing from your Python: the ability to make decisions. Think about the last time you used an app. You logged in, the app checked your password. If correct, you're in. If wrong, you're not. That check is an if statement. You opened Spotify. It looked at your history, checked what you like, and decided what to suggest. Every recommendation, every filter, every feed. All of it is a program looking at data and branching based on what it finds. Even the traffic light at corner knows if green for go, red for stop. The logic is ancient. The implementation in Python is 3 letters. Before we write a single line, understand what we're actually building. A program that can see a condition. Is this true or false? And take a different path based on the answer. That's all an if statement is, a fork in the road. Every language has this. C has it, Java has it, JavaScript has it. But Python's version is the cleanest among all of them. No curly braces, no parentheses around the condition. Just the English word if, the condition, and a colon. Here's the anatomy of an if statement. The keyword if, then the condition, a question that has yes or no for an answer, then a colon, then intended on the next line, what to do if the answer is yes. The indentation is not style, it's not a suggestion, it's the rule. Python uses indentation to know which lines belong to the if block. Get the indentation wrong, and your program does the wrong thing, or crashes entirely. But what if the condition is false? What happens then? By default, nothing. The program skips the block and moves on, but you can give it an alternative path, the else block. If the condition is true, run this. Otherwise, run that. 2 paths, 1 decision. This is the if-else pattern. It's the most fundamental decision structure in all of programming. Every time your code needs to handle 2 possible situations, one thing is true, other thing is not. This is the tool. But sometimes there aren't just 2 possibilities. Sometimes there are 3 or 5. You need to check multiple conditions in sequence and take different action for each one. Python gives you Elif, short for else if. You chain them together. If this, do that. Else if this other thing, do this instead. Else if this third thing, do something else. And finally else if nothing matched, do this. Python checks each condition from top to bottom. The moment one is true, it runs that block and skips the rest. If none are true, then else runs. So, only 1 block ever runs, never 2. Here's the simplest possible if statement. A number, a condition, and 2 paths. This condition, temperature greater than 30, is either true or false. Nothing else, no maybe. Python evaluates it and picks a path. Let's save it and then run it. As you can see, we are prompted by the terminal. It's hot, stay hydrated. 35 is greater than 30, true. First block runs, else is skipped entirely. So let's just change the temperature. Let's say, for example, 20, save it, and then run it again. Temperature is fine. 20 is not greater than 30, false. First block skipped, else runs. Same code, different data, different outcome. That's the decision. All right, let's code these out. So let's take a look at block 2. First of all, let's uncode these. Now, 3 possibilities instead of 2. Python checks from top to bottom. The moment one condition is true, it runs that block and skips everything else. Score is 78. Not 90 or above, not 80 or above, but 70 or above. Yes. So let's save it, run it. As you can see, grade C. 78 hit the 3rd condition. Python never checked the 4th or else. Only 1 block ever runs, never 2. Alright, so let's go ahead and open block 3. One more, a pattern you'll see in real software constantly. Now, 2 conditions joined with AND. Both must be true for this branch to run. So let's save it and then run it. Access granted with parental permission. The AND operator lets us combine 2 conditions into 1 check. This pattern, multiple conditions, 1 decision, is in every authentication system, every content filter, every access control layer you've ever used. One more layer. Conditions don't have to be simple. You can combine them. Python gives you 3 words: AND, or, not. AND means both must be true. Or means at least one must be true. Not flips the result. True becomes false, false becomes true. These 3 operators let you express any logical condition you can think of. Think about a login system. You let someone in if their username is correct and their password is correct. Not just one, both. That's AND. A sale applies if the customer is a member or they have a coupon. Either one is enough. That's OR. So, these are not Python-specific ideas. Boolean logic was invented by George Boole in 1854, 60 years before computers existed. He was trying to reduce human reasoning to mathematics. Python just borrowed the vocabulary. Alright, inside our block 4 Boolean operators example, let's check this line very careful now. Not flips the value. Is bound is false, not is bound is true. All 3 conditions are true, and requires all of them. So let's save this and run it. As you can see, login successful. So let's just change 1 value. Let's make this false, true, and then save it and run it again. Alright, 1 value changed, the AND chain broke. Login denied. This is how every authentication system in the world works at its core. Now the payoff. Because if statements aren't just for beginner Python exercises, they are in every serious system you've ever used, including AI. When you send a message to an AI assistant, before the model even generates a response, a series of if statements run. Is this message too long? Then trim it. Is this a follow-up to the last message? Then include context. Is this user asking for code? Then set a different system prompt. Is this content flagged as harmful by them? Then reject it. The model itself, the neural network, is mostly matrix multiplication, but the system around it, the thing that decides how to use the model, when to call it, what to send it, how to format the response. That's if statements, thousands of them, written by engineers in Python. Every AI product you use is both things at once, a powerful model underneath and a massive decision tree on top, built from the exact same syntax you just learned. 6 videos in the series: dictionaries, strings, lists, sets and tuples, composing data, and now decisions. Your code can store anything, organize it, compose it, and make decisions about it. Next video, loops, the thing that lets your code do the same decision a million times in a second. And why that matters for everything from data processing to how a language model generates one token at a time. I'm X1000, logic behind the code. Signing out.